So our first panel today is focused on the rewards, risks, and regulations of artificial intelligence in the geospatial science. The moderator for this panel is Mark Munsell. Mark serves as the National Geospatial Intelligence Agency's Deputy Director of the Data and Digital Innovation Directorate. Formerly, he was NGA's Chief Technology Officer and the Deputy Director of the Chief Information Officer IT Services Directorate. In all of these roles, Mark facilitates innovative development aimed at transforming and modernizing NGA's technology to better serve its mission partners, as well as overseeing and streamlining IT-related capabilities and services. Please welcome Mark Munsell, who will introduce our panel.
Welcome back, everybody. We've got a great panel for you here. Go ahead and come on up, everybody. We have Dalton Lunga, who's going to introduce himself from Oak Ridge National Laboratories. We have Abby, who is assistant professor at St. Louis University. And we have Patrick Wilson, who is a vice president with MediaTek. And the first thing that we did right is we got the right order as we came up, so congratulations on that.
Go us.
The first thing that I noticed was that apparently St. Louis University used ChatGPT to get my biography, which is obviously in the 10% incorrect. So whoever can update ChatGPT for us, somebody call Sam Altman from OpenAI, who, by the way, is a St. Louis native, went to John Burroughs High School here. So Gil, if you can just chat him real quick, yep, and see if you can update my biography, which will probably only cost $1 billion, right, to rebuild that foundational model. Anyway, so we're going to start with the panel here. They're actually going to do more in-depth introductions of themselves, and they're going to start with describing their hopes and dreams for this technology based in the work that they're currently doing, the research that they're doing, and the products that they're building. So Dalton, please go ahead and introduce yourself and give us an idea about what you think the awards of this technology will be in the geospatial domain.
Thank you. My name is Dalton Lunga. I lead a geospatial AI group at Oak Ridge National Laboratory. So my team and I, we've been creating AI tools and deploying these tools for transformational of geospatial data towards actionable insights, supporting a lot of national security applications. What's behind what I like to say as the big motivation behind what we do is, as Guillaume mentioned earlier on, how to reduce the latency between data generation to decision making. So a couple of examples that my team has worked on, when you look around, the frequency, intensity of natural disasters is on the increase. And, all this is due to climate change. There's a lot of destruction to property that's taking place, loss of lives. And when you look at our government, one of the things that's key in terms of responding to natural disasters is how well prepared they are. The first responders, you talk about recovery, response. They need tools that can help them to be able to attend to those situations in time. Up to about 2017, the US government did not have a comprehensive database that would help with the efficiency of determining the accuracies to assess the impact of damages across the infrastructure. So my team had that opportunity to work on a project via the Department of Homeland Security, a project that had looked at mapping all the infrastructure across the US and looking at buildings from the size of about 450 square foot. We've been able to do that over the course of 5 years. To date, we've mapped about 125 million buildings across the US and gone beyond just having the footprints, but also attributing the functional use of these buildings. That data is now critical to DHS for mitigation purposes. It's now underpinning the response and recovery that FEMA is using to attend to natural disasters when you see wildfires, tornadoes, hurricanes, the time that those teams are taking to be able to respond has been compressed as a result of having access to that data. Another example that I can also mention is with the ongoing conflict in Ukraine. At some point last year, we worked on a project that sought to map all the grain storage facilities across Ukraine so that we could help with estimating the impact of the war as it was going on. And we were able to have that data that mapped all the silos in collaboration with the Yale University. The insight that came out there was 1 in 6 of those storage facilities were impacted, were either destroyed, damaged, or within the Russian control. So that insight was useful in kind of like projecting, as the war is going on, what does the future of food security looks like. Having said that, I think I would like just to paint a timeline in terms of the evolution that I've witnessed within AI and its impact to geospatial. So when you look at the crisis management and the food security applications that we developed in Ukraine, these are tools that we're able to build using what we call supervised machine learning, meaning that we're able to classify and detect patterns in data. The human performance that we hear in the media is due to those types of tools. That's like a decade backwards looking at AI. When you move over to the past, say, 5 years, as we had from the keynote attack, generative AI tools have been coming up.
Right.
Now we've gone beyond just being able to classify the patterns. Think of when you have a pile of data, you have this AI that's acting as a metal detector to look for the needle in a haystack. But now we can understand what is in the data to a point where we can generate new content.
Right.
So with that type of capability, there's an upside. We heard about the perils that are potentially lying ahead in new applications. We are starting to think about how to design systems that we can control so that we can safeguard as we deploy and understand what are the risks that underlie these types of deployments. So when I look at the future, I foresee a future where we have a lot of emphasis in terms of human-machine teaming, adaptive intelligence tools that will help us to understand beyond just generating new content or classifying, but also planning and reasoning with scenarios that we've not yet seen. So that kind of AI is what excites me, and I think this discussion is very timely for us to engage on.
No, it's amazing, and I know a lot of this work at Oak Ridge has been built on many years, like sort of layer after layer of knowledge and work that's been done. But the fact that you can detect or use computer vision to detect millions, right? Millions and millions of buildings,
right,
and easily determine, some level of ease, determine what's happened to those, and apply that same technology to something as important as food storage, right, in Ukraine. Right. No, it's fascinating, it's amazing, and I know that our agency really appreciates the partnership that we have with Oak Ridge and your research, but I'm sure that Abby is very upset now that you've taken all of the great ideas that we've all come up with. What's interesting about Abby is she's working in a different domain of research that is equally as important and fascinating and has the potential of a different kind of award.
I appreciate the introduction. It is a hard act to follow, that description of the work going on at Oak Ridge. So I'm Abby Stylianou. I am an assistant professor of computer science here at St. Louis University and a fellow of the Taylor Geospatial Institute. My work is in sort of very broadly computer vision and machine learning and AI, but very specifically I work on global scale image search. So if I have an image, how can I find other images in a pile of hundreds of millions of other images in order to do different things? So in particular, the thing that I think about is how we can help combat child sexual abuse and human trafficking by recognizing the places where victims are being photographed. They are very often photographed in hotel rooms, and it turns out that recognizing hotels is a challenging visual recognition problem. You might have 2 hotels within the same room, within the same hotel rather, that are visually pretty dissimilar. One floor was renovated and another wasn't, and the only thing that actually matches is the lamp that gets left after the renovation. And how can you build tools that can isolate that very, very specific feature? On the flip side, every Motel 6 in the United States has been renovated to look virtually identical. And so these challenges actually make it a really interesting vision problem that I have spent the last several years working to build models to address, and that has been very satisfying. I feel lucky that I'm here at St. Louis University, where there's a real emphasis on mission and making sure that we are building tools that sort of help society. I think sort of in the broader context, this is where I see that the real opportunities of AI are. And it's not that I disagree with anything Dalton said. This is absolutely, everything was slam dunk. But I think we've all been in this field long enough that we know that things kind of didn't work for a really long time. In general, in computer vision, until about 2012, things essentially did not work at any scale. And the last decade, we've seen things sort of transition, the supervised learning revolution that Dalton referred to, sort of driven by ImageNet and these sort of benchmark models, has been really, really impactful. I think now going forward, thinking about what do these generative models mean for us, and how can we use all of this to help sort of the people among us that are most vulnerable, is a really driving factor for me. I think in some ways they are the most vulnerable to these systems as well. So I may be the biggest AI skeptic in the room, actually, despite the fact that I am an AI researcher and practitioner. I worry a lot about these models are built entirely based on huge, huge troves of data with lots of biases and lots of issues. Everything that we have that is problematic about humanity is now built into these models because we trained them on the data that came from humans. And so we're going to talk about the risks. So I view this as a huge opportunity to think about how we can use these models to help those among us who need it most. And on the flip side, making sure that we protect them as well. So I specifically think about this human trafficking problem. I know that we can sort of generalize what does it mean to be sort of vulnerable populations. I think about all of the opportunities that AI gives us for things like food security and for curing cancer, and I am very optimistic about the future. I may have more things to say when we get to the risk section as well.
So Abby, I'm going to have you, just to warn you, I'm going to have you lead that off when we come back around.
Sounds good.
Okay, Patrick, a little bit different. You're not a researcher. No. Patrick runs the government relations business at MediaTek, which is a hardware manufacturer, chip manufacturer. Mm-hmm. So, as Gil said before, this is all about compute. It is. And obviously, that demand signal and how you support that is sort of, obviously a great opportunity for your company, right? It's a positive future.
I think the whole industry is thinking about the addressable market, right? What's driving people's adoption of technology, how they put it to use, how it improves their lives. Ultimately, technologies that are ubiquitous, right? They're ubiquitous because they're useful. Right? Really powerful, cool technologies that are novel and nobody wants, there's a different file for that, right? And it's very quickly sorted. I will say thank you very much to St. Louis University, to the foundation for inviting an industry person to come. And I will say that as is my normal day job, I am very comfortable being the stupidest person in the room as a non-PhD, a mere lawyer and a lobbyist at that. What I actually do every day is I explain politics to engineers and engineering to politicians, right? And both have little interest in the work of the other, except that it's now hard to miss. So I think I was invited to the panel today to give you a bit of an industry perspective and how we see AI, and certainly the opportunities for us to help our customers solve problems, use AI for good, which is a big part of our driving force. I'm here at a moral institution today, and I thought that on behalf of industry, I should say that the semiconductor industry is very mindful of the opportunity to use technology for good, and that's a part of our history. But I want to say something different, I guess, in the opportunities category, because I think right now, maybe our focus is too intensely directed at all of the cool tools that come out of the software that we want to use AI to solve. But I want to change the direction of that gaze and make you look instead to the actual semiconductor devices themselves, because compute is the actual underlying technology. everything else is possible. So one of the things that you don't hear a lot of people talk about is that chip design is the most incredible thing in human history, right? 5,000 engineers working for 2 years across the globe is just the normal way that we design a leading edge chip. MediaTek is the fifth, depending on the count, the fourth or fifth largest fabless semiconductor company in the world. We have about 22,000 employees worldwide. We only are focused on making the next generation of chips. But what I just told you is true. 5,000 engineers working exclusively for 2 years to make one device a little bit better than the last one. What we're seeing for AI, we have been using artificial intelligence within our company, right, to improve the performance of that engineering. And what we have seen over our time in using AI is roughly a 5% performance improvement for every period of iteration. Wow. Stacking. Wow. Right? So if you thought you were good at finding image analysis and you got 5% better every 5 minutes, 5 hours, 5 days, 5 months, you see where this is going, right? And I would say for the last 10 years that I've been in the semiconductor industry, there's been a lot of writing and talking about, oh, Moore's law is slowing, right? We're not going to be able to keep up, this doubling. If you're not familiar, I urge you to ask ChatGPT, explain to me what Moore's law is, so you can do that on your own time. But Moore's law is a principle of both economics and technology that allows us to double the capability about every 2 years, 18 months to 2 years of your chips. That's why you need to buy a new phone every 2 years. Thank you for that. What we're seeing with AI is that's going to accelerate. We're going to have more powerful compute faster. We're going to make engineers that today are entering the industry, we're going to improve their performance ability, right, to make more powerful chips, and it's going to make all those solutions possible. So if what you're really talking about is crunching maps, to put it down to something, and analyzing it, pattern analysis, the good news is you're going to get a lot more of it, because the ability to process images, to identify patterns, which is really what we're about, that is going to increase exponentially because Moore's law is about to increase. I will call it right here. We are literally on the cusp of the greatest technological change since the Industrial Revolution began. The next 25 years of chip design is going to be shocking.
Yeah. No, I agree, and I think it's really fascinating where we're at. I want to riff off a little bit, it's a little bit audible here, panel, be warned. So in our industry, the geospatial industry specifically, we rely a lot on sensors. We rely a lot on satellite imageries. And there hasn't been a lot of talk, interest, energy behind designing the new generation of satellites to do artificial intelligence. It's still kind of, hey, our satellites are still going to be mostly for humans, right? And because some of these plans started 5, 6, 7 years ago. And we haven't seen a lot of energy in redesigning those sensors and satellites to this specific technology. You are getting a very high demand signal to redesign chips for this purpose. Is that right?
Yeah. People want AI in their phone, right? Right now, AI is very distant, right? It's in a computer somewhere. We were talking earlier, Dalton, about GPU, and everyone's very focused on these supercomputers like they have at Oak Ridge. But those are very narrow band of users who can use that. The idea that in only a few years, you're going to have a powerful AI tool in your pocket, right? And to be able to not only build the compute, but to connect to networks with Spectrum and other things to do that. More to the core of your question, though, Mark, and that is, I think any government, any part of the IC or DoD needs to be aware that you are riding on consumer technology. The reason you have GPU available to do these AI tasks is because 10 years ago, 13-year-olds wanted ever cooler video games, right? Luckily, video games are awesome, and people are making billions of dollars designing ever cooler video games. If that didn't happen, your mission would be in trouble, right? And I think for government to understand that you're riding on this consumer demand, right, and that you need it. You not only need it, but to leverage that, you have to have the private sector serving their customers aggressively, because that's how you can quickly use the tools for other cooler things that are unique missions.
I think the other piece of this, when we think about the satellites that you're putting up versus the phones that you're buying, we are in this really, really transformative moment. I mean, if someone with a PhD in computer science or expertise in AI tells you that they know what things are going to look like, what the landscape is going to look like in a year, run the other way. We did not see, sort of as a field, the LLM transformation coming at the rate that it did. We did not see some of these things coming. And so when you're thinking about, consumer hardware, well, okay, if it changes in a year, no big deal. If you're putting a satellite up and now the hardware or the software that you've put on that is completely out of date within a year, that's a problem.
And it's an engineering challenge too, to make technology like satellites upgradable, right? It's hard to get space, it's hard to do a launch. How do you extend the life and the practicality of really expensive assets like satellites? You need a plug-and-play modular system. So engineers are like, hey, can we figure out a way to dock a new system, right? An upgrade, just like your apps on your phone get upgraded. How do we do that for hardware? And that's something that industry is going to struggle with. Luckily, the demand for consumer products to make that happen is going to drive all the investment. So by the time you need a solution, hopefully it'll be there.
Yeah, Patrick, my family, myself personally, have been high demand consumers of GPUs over the years. And I remember struggling, a few years ago trying to get a decent GPU for our video games because of the demand from
Industry.
Yeah, the cloud computing companies and all of the folks trying to use these chips for artificial intelligence. And by the way, Modern Warfare Season 6 started 2 hours ago. So for those of you that are, hopefully your download is happening, because it's something crazy like 22 gigabytes or something. So
Schedule that for 2 a.m. Your ISP provider would urge you to do that overnight. So.
And you guys think I'm joking? That's real. I really know that.
I always make sure to do these things when I'm at SLU, so I can use the SLU network.
Right.
Uh-oh.
We're going to talk about ethics too later.
I don't actually play video games.
I know, Abby. I know. And speaking of Oak Ridge, here's a funny anecdote. A couple years ago, I was down at the Million Pixel Challenge, Billion Pixel Challenge. It keeps going up. Trillion Pixel Challenge. Yeah. Which is all the researchers on computer vision, sort of national laboratory researchers. And I asked them the question, what do you guys need? What do you need to do like what you're doing, Dalton, to do it better, right? To drive our F-scores up to like 95%, to make quality positive identification, what the director said earlier, which is our sort of ultimate goal, to have the computer do this consistently. And one after the other, they all said, more compute, more compute. Ironically, they have the world's fastest supercomputer there, and they all wanted more. So, is it still the world's fastest supercomputer?
It is.
So, Summit is still number one.
Frontier.
Frontier. I'm sorry.
Yeah. So that's the exascale.
Yeah.
Yep.
So, we're going to go to Abby here. We're going to start this risk discussion, which should be very interesting. Yep. It's fraught with promise and peril. Just exactly what Gil said earlier. From a researcher point of view, you two especially, from scientists that have to do tests and evaluation of the things that you're working on, it doesn't seem like that's a solid science right now for us to do. And so where do you see the risks in that, Abby? And can you riff off of that a little bit?
Yeah, absolutely. So thinking about the test and evaluation in particular, I think we've got to do a little bit of nitty-gritty, getting to know some details about machine learning. So for some of you, this will be remedial for whatever machine learning course you may have taken. But one of sort of the fundamental things is that you have data that you train on, which is like what makes your model work. And then you have data that you test on. And that is how you can measure, does that model that you trained on actually generalize to new data? And if it doesn't, then that model is worth nothing at all, right? You can't use it to make any new inference on any new data. And so the most important thing in machine learning is that your training data and your testing data must be separate. There can't be any mixing between those, because then if you trained on the data and you test on it, you don't know if it's actually going to work for the new thing. And so when we think about these really, really huge models that are everything everybody is all excited about right now, we don't know what they're trained on, right? These are industry proprietary models where you don't know what they're trained on. Even if you have models that they could release, they are so large that we cannot interrogate them, right? We cannot go and look through every image that goes into Stable Diffusion. We can't read through every line of text that went into ChatGPT. So we don't know what is in these models. And because we don't know what's in them, we don't know if there's any overlap between the data that we've trained on and what we've tested on. And so there's this really, really key issue that we have when we look at these huge models, that we can't evaluate them in any sort of robust scientific manner. Now, maybe if you're in this room, you don't care about that. Like, they work. Who cares, right? If we can't sort of measure the efficacy of them. But this becomes really important as we sort of think about the next generation and the next generation and the next generation. How do you actually understand how they work? When I think about the risks, though, it's that first piece of it that is so concerning to me, that you don't know what is in them. And these models are not, like, I want to make sure I don't come off as like, oh, those scary robots are going to come and take over the world, right? These are not doing anything other than pattern recognition and inferring distributions from high-dimensional data. But we don't know what predictions they will necessarily make, and so if you don't know what data they're trained on and then you don't know exactly what inference they're going to make, that's really problematic. I heard a comment sort of in the keynote talking about, well, if you're a warfighter and you're using these models, if you don't know what went into that model and you don't know exactly what predictions it can make, I'm not sure I think it makes it's a safe decision to be using them. So this data issue to me is really key to the risks.
Dalton, any ideas on what the big risks are here that you're facing, or that we're facing?
Yeah, just to expand on that, so when I look at the risks, there's another side as well, the vulnerabilities that these models comes with. A lot of the tools that we are using, they are in the open space. So if you download a pre-trained model that's already available, you have no idea to even assess whether there's some nefarious components that were injected in those models. So if you go on to do the fine-tuning, those nefarious components do carry over to wherever the decision point is at. So that's one thing. Beyond just the models themselves, I also think about the data, the output that comes out of the data. I mentioned the Food Security Ukraine data that we provided. That data was useful to pinpoint it as, to help humanitarian agencies to assess, the damages. But the same data as is could have been used on the other side to actually locate which of the remaining facilities to drop, to damage. So it's a full spectrum that goes beyond, just the data, but the models, and also how to make those models secure. When we have them within deployment production, what are the guarantees that we, build around these models to make sure that, they don't stray off, or if anybody is trying to, intrude with any invasive, attempts, those guarantees remain in place.
Right. I mean, it absolutely is an arms race, right? It is. It's a bit like cyber when we think about, hackers and defense. The fact that all these open source models that are out there is a double-edged sword. The fact that, students in high school can take an open source model and begin to do fine-tuning, train it to do other sort of different things.
Do their homework.
Yeah, do their homework. And at the same time, those models can be, used to commit crimes and collect intelligence against us and things like that. So it's good and bad. Obviously, I think that the opportunities, I'll say, I think the opportunities are greater than the risks, but it's probably to be determined.
I think to jump in a second on the other side, because we are so focused in the tasks that are assigned to compute, right? So whatever the task is, and obviously that could be a high school student trying to get out of their presidential history paper and want to use ChatGPT, or criminals, right, who could use, they just give it a task and they can use it. Let's go back to the other side, a different arms race. And this is something that I don't know if our audience has considered, but I think it's important to remember that AI for chip design is the opposite of ChatGPT, which wants to have as many users and inputs as possible, right? They want you all to stop what you're doing, use ChatGPT, because in the cycle of life for artificial intelligence, it's fail, better, faster, infinity, right? That's what they're trying to do. Find out what's wrong, you're gonna help correct the model and make it better. In chip design, it's actually a closed system, right? Because our engineers and our proprietary designs are inside the castle, right? So we can only make our chip design models better within MediaTek. MediaTek people are making our AI universe, the inputs, better. So just as Mark said, it is an arms race. Unfortunately, he who has the most engineers wins, right? Because if you have the most number of engineers inside the castle who are users, they're going to make the AI better, faster, and thus their designs are going to progress. It's a self-fulfilling prophecy. And so this is a big challenge for the United States and for our close allies like Taiwan. I would just say the democrasphere, it's a big challenge. We need to produce more engineers. And the really bad news, and I'll pass it off back to my academic friends, that electrical engineers in this country, the number that we produce has remained the same for 20 years, the exact same number of graduates. We have no improvement. Computer science, 25% on average over the last decade of growth. It's completely flat. That should concern us because other countries are exponentially improving not only the quality of their engineering education, but the yield and the number of engineers. So if it's an arms race and how many engineers you have inside the castle, the odds don't look good for us because we haven't committed it. And academia is trying to catch up. Our good friends at Purdue, MediaTek is a partner with Purdue, they said out loud, they called their shot and they said, we want to double in a decade the number of electrical engineers we produce for the semiconductor industry. We're going to do it. That's one university, but I think it's something that as a policy matter, the IC should be really concerned about that because you're going to need more engineers and you're going to compete with us. And don't tell anyone, but we pay more. So it is. You have a great mission, and that attracts a lot of engineers to want to come work for you and other related agencies. But you get my point, right? We're all fishing in the same pond. We have to grow the pool of skilled engineers who are going to help us design the technologies that will make AI of the future possible.
Thanks, Patrick. So we got about 11 minutes left. I want to solicit for questions. So if you have the app out, you have an opportunity to get us questions. We're going to spend a few minutes, and Patrick, this is probably mostly going to be focused on you, but we'll have the other panelists talk about this as well, about regulation. And so, one of the most obvious examples of regulation out there in the last couple of years is the CHIPS Act. And then, I think the White House and others are contemplating more rounds of regulation, both from a chip point of view, but also in the AI models themselves. What are your thoughts on should the United States be regulating this? And I don't know if your company is prepared to answer this question.
Not for us. I can say the industry does a lot of thinking about that, right? About government's involvement. And we have a joke, and for those of you, there are some military folks here in the room. We always have a joke about on one axis of a chart you have enthusiasm, and on the other axis of the chart you have competency, right? And so the real danger is low competency, high enthusiasm, right? And unfortunately, the semiconductor industry is very inscrutable, right? We're not obvious. And so right now it is, last night, if some of you watched the GOP presidential debate, there was a question about semiconductors. I was just, my heart was aflutter. I couldn't believe it. We're like, they know us, it's such a great thing. But for the most part, in engineering, you're suffering and you're working in silence, right? In quiet laboratories across the world. And suddenly government's enthusiasm for semiconductors is really high, right? Like a 10 out of 10. But they don't really know that much about our industry. And that's actually quite dangerous, right? Because they're, don't understand the global complexity, how every single thing we do, like I have a lot of conversations with my friends in the DoD, because I forgot to say in my bio that I've been in the Army for 16 years and I'm a civil affairs officer, so explaining technology to senior officers, I do that too. And one of the things I always say is like, well, yeah, sir, but that chip is, from a close, trusted ally like Taiwan, and it's finished in Europe, and the engineering talent comes from Holland, and it's all assembled in Connecticut, and they don't like that. That's spiraling out of the cycle of trust. And I say, no, actually, complexity is your friend. A really complicated global supply chain is a good thing. That took me a while to get there, right? Like a whole minute to explain that. And sometimes in politics, you don't get that. And so I guess back to your original question, Congress is a bit befuddled about what to do about AI. They've started to have some investigation about, moral use. And I still think government's number one tool is just oversight, asking companies, hey, how is this being used for nefarious purposes? How are you controlling it? Asking questions and information. From a regulatory standpoint, on the application side, I think industry has decided, and I say that as a member of industry, but we're thousands of companies, large and small, but I think they've decided that on the education mission, we better go first. We better create some standards, and so there is a lot of work going on in industry. I'm proud to say the Semiconductor Industry Association Technology for Good is an initiative that we have, but the industry is going to have to inform government so that they can make a better choice about where to draw lines and that sort of thing. And that's very typical for regulation over history. It takes a lot of time for them to get to a place where they make a decision.
You guys?
No,
Go ahead.
you go.
I think this complexity issue and how hard it is to get politicians to understand these things and end users to understand how they work. I will spend semesters trying to get my students to understand, like we finish a deep learning class with transformer models, which are key to how these large language models work. It is really, really hard, actually, to explain to someone how they work. And if people don't understand how they work, it is hard for them to sort of understand what the capabilities are. And if they don't understand what the capabilities are, then they are vulnerable to, say, misinformation, right? If you don't know that it is completely capable today for somebody to generate a video of Joe Biden giving a speech saying that he is going to drop a nuclear bomb on Moscow in 4 minutes and have it look completely credible, then you are going to be vulnerable to believing that. And so that, to me, is a risk both from the regulatory side and just a more general risk that these are such complex models that we can't help explain to politicians or to general end users how they work or what they can do. And so then people are going to consume the outputs of these, not realizing that they're fake.
There's been some dangerous tests of that, right? Using imagery, particularly to see how long it will be out in the wild, right? A completely inaccurate image that looks believable to see how long it takes. And I think that I think everybody, right? You understand, like we're at a kind of delicate moment within democracy, right? Because there's a lot of distrust in institutions. And so I think for technology, we really have a grave responsibility to make sure people understand the technology, what the risks are, but also to give them tools to protect themselves, because we want to prevent our adversaries, right, from utilizing these same tools, which are commercial and widely available, to destabilize our democracy, undermine our universities, undermine public trust in key institutions. All of those things are risks that I think industry is grappling with.
Yeah, Patrick, I've heard some of our policymakers say they feel like they missed, and this is straight like from senators' mouths, they feel like they missed the boat with social media, like the government should have been paying more attention on the advent of that technology, especially with children's use and things like that, and they don't want to miss the boat here. They want to get out in front of it, and the director and I have had a chance to go down to the Senate, go down and talk to some of the lawmakers, and we do see a very concerted interest and effort to pay attention to this sort of moving forward. So I'll just encourage everyone that there is positive momentum. Dalton, I'll give you a chance to talk about this real quick.
Yeah, no, I was going to say, back to Patrick's point on the oversight, I think the government needs to go beyond just the oversight. To build within its sphere the capability to be able to do the review of these technologies. They need to have R&D, scientists that understand how these tools are working. Because simply relying to the private sector, to me, kind of like spells out that conflict of interest. The very same engineers that are designing these, we're asking them to kind of like, advise the government on how to do the regulation. Yeah. So there is that balance that I think needs to be.
I agree. Yep.
To be addressed.
Yep, very good.
How do you make trust a feature of products too? And I'm going to say that again, right? When you walk in to buy a device, if you're in Best Buy or whatever, and you see them all lined up next to each other, you look at the features of technology. What's the capability of the chip? What's the memory? All these components. Right now, consumers don't have a way of measuring trust, because when we ask them, are you willing to pay more for a trusted device, it turns out they are. So that mismatch from consumer demand for trust and industry's ability to meet it, that's what I think we're going to solve as an industry. Yes, you're right, regulation is a right place and government should have a role, but I think there's also meeting the market, right? Because people are hungry for trust. They want to know, where do my products come from? Do these people share my values? And there has to be a kind of UPC, I think, for trust, so that you can value it. And if it has value, people pay for it, you'll get more of it, is my philosophy.
Speaking of trust and value, so I appreciate all of the questions. As soon as I reminded folks, I got about 50 questions here. So
it's a lightning round, go.
We're down to 3 minutes, so what I'll do is trust and values, ethics, and I'm sort of latching onto this particular question here too. This is about sort of environmental ethics. What's the panel's take on energy use demands of these models, especially as they grow in generations, future generations? I know obviously Oak Ridge is always
an energy lab, yeah.
Always wanting the world's largest, fastest supercomputer. And obviously, Patrick, you're looking to make chips that are more efficient. And then Abby, you want as much power as you can responsibly to solve your particular issues. What do you guys think about this, Dalton?
We are starting to pay attention. I mentioned earlier on about adaptive intelligence, capability. These are tools that are going to be facing, the deployment. We hear about the constraints when you deploy these models on chips that do not have enough power. You can't actually deploy them. Right. So what we are doing from an R&D point of view is to start to think about energy efficiency as a component when we are testing the new architectures. I know right now, the hype is about big models, but we are thinking about how to compress them, or even how to teach smaller models that can compute efficiently and still be able to make the same impact, however, with an emphasis on energy efficiency. So that's a very important topic.
Abby?
I struggle with this. I think there are trade-offs. These models are extremely power hungry, right? I mean, the server farms that they...
Especially to build them.
What was that?
Especially to build them.
Building them, right. So at inference time, not super hungry. On the flip side, I use not the same scale of models, but large models to do things like understand bioenergy crops. And so I think there are ways in which these large models can help us to limit our energy consumption in other ways, that we will have to weigh those trade-offs. But I think to Dalton's point, these models will get smaller.
Patrick?
On the energy efficiency, obviously, this is a good dovetail with what I said before about consumers demand it, but also just the feature size. As we're going to ship chips at 3 nanometers in the next 6 months, right? So as chips, their features get smaller, they must use less energy. So that is a problem. Obviously, there's leakages, and just heat is the enemy of all chip capacity. But the other thing is something I mentioned before about interoperability, the ability to get more efficiency from sensors. One of the awesome things about the fact that we've driven down the price of sensors is, if you haven't noticed, sensors are everywhere. Right now, I can pull out my phone, and at our house in Virginia, which is currently empty, I can tell you, I can control my thermostat and what the temperature is room by room in my house in Virginia while I'm here. That's an amazing tool for energy efficiency, and we're seeing that. Like, the utilities are having a problem because we're consuming less energy, but they need to spend more money. And it's the same for cars. The biggest crisis right now is energy efficiency in cars, because we pay for our roads with gas taxes. Well, we're consuming less gas, so we're like, we need more roads because of, EVs.
Fascinating news article came out yesterday.
Super confusing.
Microsoft is seeking nuclear engineers.
Yes.
So that they're sort of designing the future data centers to run on nuclear power. So
independent nuclear
everything's
power.
sort of independent.
They want to have these small modular reactors that will
So
just be there. It's
just another facet of how fascinating and how our world is changing so quickly from the demand of this technology. So I want to thank you guys. It was a great panel, very insightful, all the different angles to approach this. And I think our audience really appreciated this conversation. So thank you.
Thank you very much for having me.
Thank you.
Thank you.